Martian Metropolis. Science writing by Meg Thatcher. NASA plans to send humans to Mars in the 2030s, and several private entities aim to send settlers to live on Mars permanently. There are several reasons to create an off-planet colony. One is survival of our species. We never know what will happen to threaten the habitat. This could be our life raft, says Darby Dyer, an astronomy professor at Mount Holyoke College and a member of the Mars Curiosity rover team. There's also the cool factor, she says. Who would not want to live on Mars? Scientists living on Mars can study the planet up close better than rovers can. They can compare it to Earth and other planets. They can study its atmosphere and humans' effect on that atmosphere. If they find evidence for life on Mars, whether past or present, that will tell humans we're not alone in the universe. Fourth rock from the Sun. Of all the planets in the solar system, Mars is the most Earth-like. It's made of rock and has a thin atmosphere. The scenery is beautiful, but also strange, with craters and sand dunes, dust and scattered rocks. It has massive landforms, the tallest mountains and deepest canyons in the solar system, all under a pink sky. It's farther from the Sun than Earth, so Mars is much colder. On average, it's a bone-chilling -80 degrees Fahrenheit, -62 degrees Celsius. The Martian day, called a sol, is about 40 minutes longer than an Earth day. A Martian year is 668.6 sols. Its atmosphere is about 100 times thinner than Earth's, and it's 95% carbon dioxide. Even if Mars's atmosphere were thicker, we wouldn't be able to breathe it. Earth's atmosphere is mostly nitrogen and oxygen, with 0.04% carbon dioxide, a combination that's friendlier to our planet's life forms. The biggest danger on Mars, though, is radiation. Mars has no magnetic field to protect humans from high-energy particles from the Sun and other sources, called cosmic rays. On Mars, cosmic radiation is much higher than it is on Earth. This can cause serious damage to DNA, which increases the risk of cancer. The danger decreases if you burrow 16 feet, 5 meters, under the surface of the red planet. The soil overhead would provide about the same amount of protection as Earth's atmosphere. Living off the land. Sending stuff to Mars is very expensive. The cheapest way to colonize will be to make everything there. It's really all about the resources, says Dyer. If we find things there that allow us to sustain human life, then we can settle there. Mars has plenty of metals and rock, and probably lots of water, but no wood or petroleum, which is used to make gasoline, plastic, and many other useful products. The settlers could make bricks from local dirt. Mars has plenty of silicon and iron, elements that will allow people to produce glass and steel. And of course, everything sent to Mars will stay on Mars. Martian citizens will be really good at recycling. Settlers will need to grow food. Mars has dirt, but it doesn't have soil. Soil contains microbes that help plants grow. Fortunately, humans will take those organisms along with them. Poop makes excellent fertilizer, so the sewage treatment plant will be near the greenhouses. Martians will most likely eat a vegan diet. Animals are hard to transport, and it takes much less energy to grow plants than to raise animals. Plants also use up carbon dioxide and produce oxygen, which people need to breathe. The city will need energy for heat and electricity. The best sources will be solar, geothermal, and wind, as there's no oil or gas on Mars. Settlers will also want to make fuel for trips back home. They'll likely use carbon dioxide from the Martian atmosphere to make methane gas. To do this, they'll need hydrogen. They could bring it from Earth, or get it from water found on Mars. Smaller is better. Because it has to produce its own air, the Martian city will be small. At first, residents will probably live underground to protect against cosmic radiation. They'll work to develop radiation-blocking glass or plastic. Once that's in place, settlers can live above ground in brick buildings with windows, or even under a dome or tent. To limit exposure to radiation, scientists will send rovers and drones out exploring, and will use the information to decide where to send human explorers. Temporary shelters and labs will pop up all over the planet for short-term science projects. Wealthy tourists might visit the red planet, but you won't have to be rich or a scientist to live on Mars. The city will need farmers to grow crops, cooks, people to run the spaceport and sewage plant, trash collectors, doctors, and nurses. The list goes on. Some jobs can be done by machines, which use fewer resources than human workers. So add robot mechanic to that list of careers. All work and no play? Colonists will keep busy with work, but they'll want entertainment too. They can venture outside for short sightseeing trips. They'll have television, radio, and movies, some transmitted from Earth, some made right on Mars. They can read and do crafts. Colonists will probably make up new sports that take advantage of Mars's low gravity. Zip lines, rock climbing, and trampolines will be popular. But travel will be hard. The most fuel-efficient trip back to Earth, using gravity to do most of the work, will take around 6 to 8 months. Earth and Mars are properly aligned for this trip for about 20 days every 26 months. Travelers in a spaceship will experience more radiation than people get on Earth. Our muscles will weaken unless engineers create artificial gravity by spinning the ships. It adds up to a lot of wear and tear. Humans will keep trips to a minimum. But people on Mars will communicate with Earth pretty often. Because Earth and Mars are so far apart, signals are delayed by up to 24 minutes. Communication will mostly resemble email. Jay Dixon, a planetary geologist at Brown University, has lived at Antarctica's isolated McMurdo Station. Just being able to send pictures back and forth is great for morale, Dixon explains. A colony on Mars will be humankind's first steps in expanding our reach within the solar system and beyond. The author wishes to acknowledge the factual contributions of the space exploration experts consulted for this article.